What's up, everybody? Welcome back to another live stream from Scalar Learning. My name is Huzaifa, and today we are continuing to go through ALEKS. What is ALEKS? ALEKS is an online math curriculum, and it's amazing. It's got all sorts of exercises and trajectories, and something that it's really famous for is the ALEKS Pi. So I'm doing pre-algebra, so for all of you who are out there working through ALEKS maybe this year or over the summer for extracurricular practice in math to get you sharpened up for the school year that's right around the corner. Hopefully this will give you some help and guidance as to how to navigate this program. For those of you not familiar and just want to kind of brush up on pre-algebra, you're welcome to watch along and learn. I'm going to probably do this for about an hour and a half today, maybe longer if I can handle it. So we're picking back up with where we left off last time.
About an hour.
And we left off at 66%. Without further ado, here we go. 66%. All right, let's do it. Okay, determining if figures are related by a dilation. So here we're just trying to see if these figures are related by dilation. We can see that they are when we move it down and match it up like that. And if we cannot do that, then we say it is not possible, but it's possible for both of them. There we go. Next. This one clearly is not possible. And this one should be, boom. All right, topic done. Let's continue. Finding sample size and comparing samples for estimating the mean. Caitlin and Jane want to find the mean amount of time it takes students in their class to travel to school. So they each randomly select students in their class and ask for the times. The results are shown below. Here's Caitlin's sample, here's Jane's sample. What is the size of for Caitlin's sample? 1, 2, 3, 4, 5. So it looks like she's got 5 pieces of data. She has 5 people. What about Jane's? We got 1, 2, 3, 4, 5, 6, 7, 8. She asked 8 people. Suppose I had to choose one sample, which one would likely give a good estimate? Well, usually, this doesn't always necessarily will be the truth, but usually the larger sample is better. We have more people, therefore, it's likely to be a better spread and more accurate, more representative. And I would say, okay, why? It's because it has the larger sampler size. And that's it. Next one, same dealio. So I'm going to kind of skip this whole chunk here because it's probably the same thing. We got 2 samples. What is the size of Tom's? That's 5. Bob's is 4. And I'm going to say that Tom's is probably better because it's bigger. And same thing, it has a larger sample size. Okay, last but not least, sample size for Philippe's is 1, 2, 3, 4, 5, 6, 7, 8. For Rita is 1, 2, 3, 4, 5, 6. Oops. Which one is better? I would say again Philippe's because it's got a larger sample size. So it's the same here. Okay, using a scale drawing to find actual area. A scale drawing for a restaurant is shown below. In the drawing, 1 centimeter represents 3 meters. So 1 centimeter represents 3 meters. Assuming the dining hall is rectangular, find the area of the real dining hall. So in this case, when we just want the area of the dining hall, right? So I can see that we've got this image here. I'm just going to transfer it, just so I can write this out and show you exactly what I'm doing here. So again, based on what we've been given, since 1 centimeter is 3 meters, 4 centimeters is 4 times 3 is 12 meters. This one down here is 3 centimeters. 3 times, again, 3 centimeters, which each centimeter is a meter, 3 meters, excuse me. So that's 3 times 3, which is 9. So it's 9 by 12 meters. Therefore, the area of the real dining hall is 9 times 12, which is 108 meters squared. Same deal, we want the area of the real bedroom. So here, again, 2 centimeters equals 3 meters. So we could even set up a proportion like this. We can say 2 centimeters is the same as 3 meters. And then I'm going to convert 4 centimeters to X amount of meters. So first I'm going to find this value here. Okay, we can do that by cross multiplying. And we get 12 equals 2x. Divide both sides by 2. And I say that x equals 6 meters. So this length here is 6 meters, right? We were kind of converting the 4 to the new value, which is 6. Now I'm going to convert this 8 centimeters. So I'm just using a proportion. I'm going to say 8 centimeters. Whoops. Again, we're using the same starting point. 2 centimeters is equivalent to 3 meters, and then set it equal to 8 centimeters is equivalent to x meters. That's what we're solving for. Okay, now we cross multiply. 8 times 3 is 24. 2 times x is 2x. Divide by 2. And we get x equals 12. So the other side is 12 meters. Okay. And now what's the area? Well, it's 6 times 12, which is 72. Okay, we want the area of the real backyard. So again, 4 centimeters represents 5 meters. So we're going to set up a similar proportion. Remember, the dimensions are 4 by 12. And let's convert these both to the meter value. So I can say 4 centimeters is equivalent to 5 meters. And then this is our kind of scale proportion. And then now we're converting, well, we already know 4 centimeters is 5 meters. So the new one is 5 meters. We don't even have to use the proportion there. I know straight away. And then by 12 centimeters, let's convert our 12 centimeters is equivalent to how many meters? Let's find out. Set it up, and then we cross multiply. 12 times 5 is 60. 4 times x is 4x. Divide both sides by 4, and we get x equals 15. So these are the dimensions of the real backyard. So 5 times 15 is 75. Finding simple interest without a calculator. Jessica deposits $2,000 into an account that pays simple interest at 6% per year. How much interest will she be paid in the first 3 years? So this is how simple interest works. First of all we need to do is take 6% of this value. So that's the first step. So 6%, we can't use a calculator. Convert that to a decimal, which is 0.06, and then multiply it by 2,000. Okay, and we get 0, 0, 0, 12. Now, we don't even need to multiply the 0 out because it's going to be all zeros. It doesn't matter. But then where do we place the decimal? Since there are 2 digits to the right of the decimal, we go 1, 2, move it 2 digits to the left, and it's $120. Now, that's for 1 year. Simple interest, it's just whatever she makes that first year, she makes the same the second year, makes the same the third year. So for 3 years, she's making $360. I added them there, could have just multiplied it by 3 as well, same thing. Next, 5% of $800. And how much will she make in 5 years? Same thing. Let's turn that 5% into the decimal equivalent of 0.05. Multiply it by 800. Move the decimal once, twice. So that's $40. But times 5, because we're doing it for 5 years. And that's in total value of $200. All right, here we go. 6,000 that pays simple interest of 3%. So let's calculate our 3% of 6,000. Move the decimal over twice. It's $180. How much will she be paid in 6 years? Well, now I'm just multiplying that times 180. 1080. All right. Determining if figures are congruent and related by a transformation. Are figures A and B congruent? Congruent means equal. And I can see here they are not congruent. They're not equal, so no. Which transformation will map figure A onto figure B exactly? Well, guess what? If they're not congruent, there's nothing. So you can't do it, period. Therefore, it's none of these. Next, are these congruent? Yeah, they look congruent. I can tell. Like, they got the same side here. You know, just different orientation, same length. It's the same shape. Now, how do we get it here to here? To me, it looks like a 90-degree rotation, right? We kind of bring it down here, a 90-degree rotation about the origin clockwise. So they're going in the same direction as a clock. So that's my guess. So let's see. Figure 9, clockwise rotation about the origin. Boom. Counterclockwise would be going this way. Let's see if that's right. Yes. These two look like they're congruent. So yes, these are congruent. These also look like they're congruent. Now, how do we get it from here to here? This looks like perfectly symmetric, these two figures. When that's the case, it's a reflection. Doesn't it look like these are reflections of each other? It's a reflection across the y-axis, and that's it. What about here? Which transformation? This looks like a slide, or what we call translation, to the right. How many units? Well, it looks like it's gone 1, 2, 3, 4, 5, 6, right? So it's gone 6 units to the right. Oh, I'm sorry, going from C to D. Excuse me. So C to D, we're going 6 units to the left. And there we go. Okay, final one. These look congruent to me. These look congruent to me as well. This looks like a translation down by, let's see, 1, 2, 3, 4, 5, 6, 7, 8. This one looks like a rotation, boom, clockwise, 90 degrees. Right? We're going rotating it up. That looks good to me. All right, next topic. Finding side lengths of rectangles given one dimension and an area or a perimeter. The perimeter of a rectangular garden is 362. If the width is 84, what is its length? So here's how we got to figure this out. We know that perimeter is adding up all the sides. So it'd be x plus 84 plus 84. And all of this equals 362. Now we just got to isolate and solve for x. So 84 plus 84 is 168. X plus x is 2x equals 362. I'm going to subtract 168 from both sides, so I'm trying to isolate. 2x equals, let's see, this is 194, I think. I can use a calculator, so maybe I will. Let's see. And then I divide both sides by 2, and x equals 97. So I believe the length is 97. Let's double check our math here. 362 minus 168 divided by 2. Yes, 97. All right, cool. So that's good. And then let's try the second one. A rectangular window has an area of 7227. If the length is 99, what is the width? Well, the width times the length equals the area. That's our equation. Now we just isolate for width. So let's use our calculator here. 7227 divided by 99 equals, nice whole number of 73. Next, let's get our, I assume these will be all rectangles, so let's kind of keep it set up here. The area is 6370. The width is 65. The length we don't know. So our equation again is length times width equals 6370. Isolate by dividing both sides by 65. Let's see if I can do it in my head. I can't. I think it's 98. I want to guess. 6370 divided by 65 equals 98. That's what I thought. Okay, next, perimeter. Perimeter of a pool is 348. The length is 93. The width is what? Okay, I'll use W this time for width. So a shortcut is I could say 2 times W plus 2 times 93 equals 348. Because 2 times this, which is this plus this, 2 times this plus this, add these up and they all equals 348. 2 times 93 is 186. Now let's isolate for W. So I'm going to subtract 186 from both sides. And we get 2W equals 261. So 162. Divide both sides by 2. W equals 81. Next, perimeter of a rectangle is 322. Length is 89. Width is what? 2W plus 2 times 89 equals that. 2W plus 178. $2W equals 144. W equals 72. Right? Let's make sure that's right. 72, 144, 310. 72, yeah. There we go. And last but not least, boom, the area here is 8342. Width is 86, length is x. So again, x times 86 equals 342. Divide both sides by 86. Eight, 3, 4, 2 divided by 86 equals 97. All right, let's keep going. Evaluating expressions with exponents of 0. So this is really cool. This is all about the exponential rule of 0, where anything to the 0th power is 1. So guess what? -5 to the 0th power is just 1. Now here's a little interesting, right? We got -2 times 1/9 to the 0th power. Well, just the 1/9 is to the 0th power. So this part turns into 1. Still multiplying the -2. -2 times 1 is just -2. Next, again, that 7/2 is raised to the 0th power, so that's just 1. 1 times -3, which is -3. Now we got this thing here in the parentheses going to the 0th power. That's 1, but then the negative is outside, so the negative doesn't hit it until the exponent evaluates, so it turns it negative, so it's still -1. Last but not least, 3 to the 0th is 1. This inside the parentheses turns to 1, then hits the negative sign, so we got -1. Estimating a tip without a calculator. Estimate a 20% tip on a dinner bill of $169.37 by first rounding the bill amount to the nearest $10. Well, that estimate's going to be pretty simple, right? I'm going to turn it to 170, super close to 170. Now, I do this all the time in real life. If we're trying to estimate 20% in our heads, okay, the really simple trick is it's just like multiplying this entire thing by 2. So if I multiply this whole thing by 2, I get 340. I double it, but then I move the decimal one spot to the left because that's like multiplying by 0.2, right? Which is 20%. So we move the decimal one spot over, and it's 34. So the trick is you double it and then move the decimal one spot to the left, and it's $34. Next, I'm going to turn this to the nearest $10, so it's really close to 40, not 50. So we're going to say it's 40. Now we do 5%, right? So it's the same deal here. Multiply it by 5, which is 200. But in this case, since it's 0.05, we'd have to move the decimal 2 spots to the left. Okay, not 1 spot, 2 spots to the left, and it's $2. Okay, last but not least, 15%. This is something you have to do often as well. So round to the nearest $10. I'm going to put this at 30. Now here's my trick with 15%. First, I take 10% of 30. 10% of 30 is just the number itself with the decimal moved over 1 spot. So 10% is 30. And then, since I want 15%, I need another 5%. Well, the nice thing is 5% is just half of 10%. So if 10% is 3, 5% should be half of that, which is $1.50. So 15% is just these two added up, which is $4.50. Next, okay, finding the sale price without a calculator given the original price and percent discount. An item on sale costs 80% of the original price. So an item on sale costs 80% of the original price. If the original price is 90, what is the sale price? So the original price is 90, and we want to find the sale price. The sale price is 80% of this. So I'd multiply it by, move the decimal over twice, convert it to a decimal, which is 0.8. Do the multiplication, 0.72. Move the decimal over by 1 because one number to the right of the decimal, move it once over to the left. Sale price is 72. Next, an item regularly priced at $80, and then she bought it on sale for 15% off the regular price. What you can do in this case is find 15% of 80 and then subtract that from 80. I'm a fan of doing something else, which is, well, I know I'm taking 15% off, which means the new price is going to be 85% of $80. So if I want to find 85% of 80, it's one step instead of two. Just do 0.85, right? Move the decimal over twice and multiply. 0.85 times 80, 5 times 0, 5 times 8 is 40, 0, 0, 8 times 8 is 64. We got two numbers to the right of the decimal, so I move it once, twice to the left. And we got a price of $68. Final question, the price has been reduced by 25%. The original price was 60. What's the price of the item now? Again, the price is 75% of the original price. So 0.75 times 60 equals. Okay, so I'm doing the multiplication here. 0, 0, 5, 4. Move the decimal over twice. Same thing because I got two decimals to the right. It's $45. Identifying solutions to a linear equation in two variables. For each ordered pair, determine whether it is a solution of this guy. Okay, what we're doing here is, what we're doing in this problem is I've got a function and I'm trying to see if these coordinates, if I plug them into this equation, if it works essentially. The way to do this is, and now this is a unique one because it's a single variable equation, it's just y equals -1. So there's a really easy shortcut in this one. I don't even have to plug these values in per se. All I'm plugging in is the y value, and guess what? The y value always has to equal -1 because that's just like, what is the equation? So anywhere where y is not -1, right? Here it's 5, here it's -8, here it's 9. Those are not solutions. Only here is it -1. That's the only solution. Now we have a two variable equation, so now it gets a little more interesting. Now we need to plug in all these values and make sure they evaluate out, meaning when if I plug in these two values and I get -29 on this side, I know it's a solution. So 5 times, I'm going to replace the x with -9, and I'm going to replace the y with -2. This becomes -45. This becomes minus a negative becomes a positive, so positive 16. -45 plus 16 is -35. It's -29. So I get -29 equals -29, therefore it's a solution. Now let's plug in the next one, which is -3. Oops. -3 and 1. -15 minus 8, that's -23. This is not a solution because it doesn't equal -29. Next, let's try 0 and -4. So 5 times 0 goes away. -8 times -4 is positive 32. This is not a solution. Last but not least, 6 and 5. 30 minus, that's 40, equals -10. That's not a solution. Okay. Last but not least, y equals 7x minus 2. Okay. -6, -44. Let's plug them in. -44 equals 7 times -6 minus 2. This becomes -42 minus 2, which is -44. So we got the same number on both sides, therefore, yes, it's a solution. Let's try the next one. Remember, you got to make sure to put the y on the left, not on the right. So that can be a little confusing. 23 here. The x is -3. So this becomes -21 minus 2, which is -23, does not equal positive 23. All right, next, 47 equals 7. 7 times 7 is 49 minus 2 is indeed 47. Last but not least, -14 equals 7 times 8. 14 equals 56 minus 2. This, of course, does not equal -14. Therefore, no. Graphing a vertical or horizontal line. All right, when we got something like this, when it's x equals -1, anytime it's x equals something, it's a vertical line. If it's y equals something, it's a horizontal line. Now, the way that I always think about it is, well, wait a minute. So this is x equals -1. Well, that means x equals -1 here when y equals 0. But when y equals 2, x equals -1. When y equals 4, x equals -1, so on and so forth. So for any value of y, x equals -1. And that's how you can see you get your vertical line. Next, x equals 3, same thing. When y equals 0, x equals 3. When y equals 4, x equals 3, so on and so forth. For every value of y, x equals 3. Next, y equals -7. Let's find -7 on the y value. So when x equals 0, y equals -7. But when x equals, let's say 5, y equals -7. Boom, all the way across. That's how you get your horizontal line. All right, next. Finding the slope and y-intercept of a line given its equation in the form y equals mx plus b. That is slope-intercept form. And slope-intercept form y equals mx plus b means that you can tell a lot from the line, meaning whatever here is multiplying the x is our slope value. Whatever value is over here is our y-intercept. Slope is the rate of change, meaning how fast is it rising? Is it like that? Is it like that? So on and so forth. Just like the steepness of a hill. Y-intercept is where does it cross the y-axis. Okay, so this would be related to our b value right here. So again, the y-intercept in this case, since there is no x value, there's nothing multiplying the slope. Slope is actually 0. But now there's another option. The slope could be undefined. Now, how do I know it's a slope of 0? Well, because here in this case, 0 would be multiplying x, and that's why it's not there. The other reason why I know this is when it's y equals a constant, it's a horizontal line, meaning it's a flat line, horizontal like that, and that's a slope of 0. A vertical line has an undefined slope. My y-intercept is this constant right there, which is -3/2. Okay, next. Now here, my y-intercept, my slope is -9 because that's that number multiplying the x. Okay, I could rearrange this equation to be y equals -9x minus 8. Now it's more fitting with this, and my y-intercept is this term right here, the -8. All right, now here's my equation, y equals x plus 9. Well, what's multiplying the x here? It's actually an invisible 1. Therefore, the slope is 1. What about my y-intercept? That's 9, which is sitting right out there, and that's that. I'm going to log out quickly and log back in. That often will help speed up the processing. Sometimes it slows a little bit. Okay. All right. Understanding the power rules of exponents. Here we go. So here we're doing 3n and this whole value squared. So what's happening here is we're actually squaring this entire entity. The first way to think about it is it's 3n times 3n, where these guys multiply each other, these guys multiply each other, and we get 9n squared. The other way to think about it is this 2 squares each of these guys, or it multiplies their exponents, but they both have exponents of 1. So it becomes 3 squared n squared, which is again 9n squared. Both ways are fine to think about it. So if I want to write this without exponents, I can write it as 9 times n, right? 9n squared, that's just, that's what I could have written here as 3 times n, or 9 times n. And then now I can also write it as 9n squared. Okay, next, we want to write this without exponents. Now, in this case, that exponent does not apply to the 3 because there's no parentheses. It only applies to that a. So we'd write this as 3 times a times a times a, right? A to the third is 3 a's multiplying each other. And we could, again, rewrite it in the original format. Last but not least, now we get to apply that nice rule of the exponent multiplication. So if it's b to the 4th squared, that 2 multiplies that. This actually becomes b to the 8th, which is 8 b's all multiplying each other. So it's b times b times b times b times b times b. Or it's b to the 8th. Okay, next. Finding side lengths of squares given an area and a perimeter. A square has an area of 144 meters squared. What is the length of each side? Well, again, we can think about a square as having all equal sides, x by x. So x times x, or x squared in this case, equals 144. To solve for this, I'm going to take the square root of both sides, undoing that square. And we get our final answer. Square root of 144 is 12. Okay. Now we have another question where we have a perimeter of 8. Okay. So for this same square, we know the perimeter is x plus x plus x plus x equals 8, meaning 4x plus 4x equals 8. Divide both sides by 4, and x equals 2. So the side lengths are 2. Okay, same thing, perimeter. So if we're talking about perimeter of a square, if we follow that same process as before, we're just dividing this by 4, right, to get each of the 4 sides. So 88 divided by 4 is 22, and we can test that. 22 plus 22 plus 22 plus 22 is 88. If it has an area of 25, we just got to take the square root of that to get the side lengths, which is 5. Same thing, has a perimeter of 144. So we need to divide this by 4 to get each side length. I believe that is 36. Just double check. Yeah, it's 36. And then it has an area of 36. Take the square root of that to get the side length of 6. Establishing facts about the angles created when parallel lines are cut by a transversal. Oops. 2 parallel lines G and H are cut by transversal B. Suppose angle M, which is, 1, is 75. Okay, let's complete the statements below. I see that 1 and 2 are, so 1 and 2, angles that are opposite like this are actually called vertical angles. Vertical angles are always equal. And therefore they are congruent. Congruent is a synonym for equal. So therefore angle 2 has to be the same, has to be 75, just like that, angle 1. We see that angles, you know what, let me move this so we can, it's a little easier to see. We see that angles 2 and 3 are also, they're not vertical, but these are what are called corresponding angles. When we have angles here and here, it's kind of like, they almost look the exact same, right? Same side of the transversal, etc. These are called corresponding angles, and they're also congruent, which means angle 3 is also 75. Angles 1 and 3, since these are also congruent, and these are congruent, 1 and 3 are also congruent. And now, what are 1 and 3? 1 and 3 are what we call alternate exterior angles, right? They're on alternate sides of the transversal, and they're both on the outside of these parallel lines. When parallel lines are cut by a transversal, alternate exterior angles are congruent, and that's what we just proved. Next. Let's take this right off the bat. We see that 2 and 3, now the 2 and 3 are congruent, okay? Because they're corresponding angles. 2 and 1, just like before, are vertical angles, so those are also equal. So 2 and 3 are corresponding angles, and which means they are congruent. So angle 3 is 115. It's the same. Angles 1 and 2 are vertical angles, so they are also congruent. And angle 1 is also 115. Therefore, angles 1 and 3 are congruent. They are also, okay, now, angles 1 and 3 are what are called alternate interior angles because they're on the inside of these vertical lines. Therefore, alternate interior angles are congruent. Oops. Okay. Angles 1 and 2 are equal. 2 and 3 are equal. So 1 and 2 are vertical angles, right? They're across from each other. They're congruent. Therefore, angle 2 is 60. 2 and 3 are corresponding angles because they're like the same side of the transversal. They are congruent. Angle 3 is also 60. Angle 1 and 3 are therefore congruent. They are 60. I'm sorry. 1 and 3 are alternate interior. Again, opposite sides of the transversal. That's why they're alternate, but they're interior on the insides of these parallel lines. Alternate interior angles are therefore congruent. Using a calculator to convert a fraction to a rounded percentage. Okay, let's convert this to a percentage. So the way to do it, the way that I'm going to do it, is we literally first just turn this into a decimal by carrying out the division, meaning I'm going to divide 53 by 16, numerator by the denominator. And that's 3.3125. Now, if we remember DFP down for the party, decimal to percentage, if I'm turning a decimal, which this is, to a percentage, I move the decimal to the right twice. So same thing, I move this once, twice, and this is 331.25%. And we want to the nearest tenth. So I'm going to round up to 0.3, round up, 331.3%. All right, same dealio. We got 8 over 23, so I'm going to do division. 8 divided by 23, numerator divided by denominator, and we get 0.3478. I'm just going to write a few, whatever. Down for the party DFP, move it once, twice. And we get 34 point rounded up to the 8%. Last but not least, 5 over 80. 5 divided by 80. I'm going to move the decimal twice to the right, and I get 6.25, or rounded to the nearest tenth, 6.3%. Oops. C's. All right, here we go. Finding a percentage of a total amount in a circle graph. The circle graph shows how the annual budget for a company is divided by department. If the total annual budget is $5 million, what amount is budgeted for marketing? Okay. So marketing is 22%. 22% of what? Well, of this whole 5 million. So if we want 22%, we need to convert this to a decimal by moving the decimal spot once, twice to the left. So it's 0.22 times 5 million. Now, we're allowed to use a calculator, so let's go ahead and do that. It's just 0.22 times 123. And it's 101.1 million. And you can even copy this and then paste it in. And there we go. Okay, same thing. 60,000 citizens answered, meaning 66,000 is the whole. How many chose dog? Well, we just take 23% of 60,000. So again, I'm going to take the decimal equivalent of 23, which is 0.23, and multiply that times 123, 60,000. And we get 13,800. Okay, last but not least, 13,500 is the total. How many chose purple? 16% of that, so 0.16 times 13,500, which equals 2160. All right. Solving a linear equation with several occurrences of the variables on the same side, I guess that is. Here we go. So here's what I'm going to do. I'm going to write this up here, and then I'm going to show you how we're going to evaluate it step by step. First thing is we see parentheses. We need to get rid of those parentheses. That's always going to be my first step. So how do I do that? I'm going to distribute across, because I can't evaluate this. I can't combine these terms. They're not like terms. So we get 6u plus 2u. 2 times 7 is 14. 2u minus 14 equals 18. Now I'm going to combine these like terms. 6u plus 2u is 8u. Now that we've done that, now it's all about isolation. We only got one instance of u. Let's isolate it. So I'm going to move the 14 over by adding 14 to both sides. And I got 8u equals 32. And then to get rid of 8 is multiplying the u. We do the opposite, which is divide both sides by u. I mean by 8, excuse me. And then u equals 32 divided by 8, which is 4. Next. First of all, distribute 5x plus 5 times 7 is 35 plus 6x equals -9. Now I'm going to combine my like terms. 5x plus 6x is 11x plus 35 equals -9. Now let's isolate. Let's move the 35 over by subtracting both sides by 35. 11x equals -44. And then let's divide both sides by 11. And we get x equals -4. For w plus 5 times w minus 6 equals 6. Distribute the 5, and I get 4w plus 5w minus 30 equals 6. 4w plus 5w, like terms, equals 9w. Now let's add 30 to both sides, and we get 9w equals 36. Divide both sides by 9, and I've got w equals 4. All right. Evaluating an expression with a negative exponent whole number base. Okay, here's how we deal with negative exponents. Negative exponent is the same as 1 over this quantity with a positive exponent. That's it. Super simple. Now we just got to figure out what's 3 to the 4th. Well, it's 3 times 3 times 3 times 3. And if we calculate this out, 3 times 3 is 9, times 3 is 27, times 3 is 81. One over 7 to the negative 2. Now this is interesting because it's already below 1. But the thing is, when it's already below 1, to turn it back to positive, we just bring it up. And it becomes 7 squared. So if we see a negative exponent like this in the denominator, we just flip it up to the numerator and make that positive. So it's 7 squared, which of course is 49. Last but not least, 4 to the negative 3rd. Again, that's just 1 over 4 to the positive 3 exponent. 4 cubed is 4 times 4 times 4. 4 times 4 is 16. Times 4 again is 64. So it's 1 over 64. Scientific notation with negative exponent. Okay, 0.000997. Place this in scientific notation. I only want one non-zero number to the left of the decimal, meaning I have to move the decimal once, twice, 3 times, 4 times. Okay, so it's 9.97, and now since I've moved the decimal over, I need to represent that in the 10, right? That's how scientific notation works. It's this times 10 to some power. Well, to accommodate for moving the decimal once, twice, 3 times, 4 times to the right, I have to balance it out with a negative 4. So again, here I'm moving the decimal and I'm making this number bigger by a factor of 10 to the 4th. So to balance it out, to have the right value, I need to multiply it by 10 to the negative 4th. Because again, if I evaluated this, it would bring it back to our original. So it's 9.97 times 10 to the negative 4. Next. So I'm going to move the decimal once, twice, 3 times. So I got 4.26 times 10 to the negative 3rd because I moved it 3 times. 4. Now we're going the other way to standard notation. 10 to the negative 4th. So if I want to get it back to its standard notation, since this is negative 4, I move it 4 times to the left. Once, twice, 3 times, 4 times. And fill those blanks in with zeros. So it's 0.1239722. Oops. Maybe put a 0 in front. Okay. Establishing facts about the interior and exterior angles of a triangle. Okay. Oops. I want to move this over here. Hey, what happened? Oh, whoops. Here we go. Okay. The sum of the interior angle measures of a triangle must be 180 degrees. That's always true. So therefore 2 plus 3 plus 4, 2 plus 3 plus 4 must equal 180. Yes. Now we know that angle 2 equals 76. So let's put that in here. So then 3 plus 4 must equal, well, if this is 76, these two must add up to 104. Why? Because 104 plus 76 is 180. Therefore 3 plus 4 must equal 104. And now I can see that 1 plus 2, what must 1 plus 2 equal? Well, these are along a straight line. Straight line is 180 degrees, therefore 1 plus 2 must equal 180. Since this is 76, oh, this must also equal 104. Oops, and this is showing us a really interesting rule. Therefore, angle 1 equals 3 plus 4, right? Because if this angle over here is 104, whoops, and I know these two are 104, well, they equal each other. And this is called the exterior angle property of triangles. The measure of any exterior angle equals the sum of the measure of the two remote interior angles, in this case 3 and 4. Okay, next. Okay, here we go. 1 plus 2 plus 4. So all the angles must equal 180. Same deal. Therefore, these add up to 180. Angle 4 equals 35, right? Let's put these values in. 4 equals 35, and angle 2 equals 44. If 4 equals 35, that means angle 1 plus angle 2 must equal 180. So, okay, here. 180 minus 35 equals 145. So angle 1 plus 2 must equal 145. 3 plus 4 also equals 180 because it's a straight angle. Therefore, angle 3 must equal 145. So guess what? It's the same rule. Exterior angle equals the sum of the remote interior. I'm feeling like this is going to be the exact same, so if it is, I'm going to go kind of fast here. These all equal 180. 180. 3 equals 62. Oh, let's see, it's a little different. 3 equals 62. And 4 equals 74. 3 plus 4 equals 136. Therefore, angle 1 must be 44, right? Because 44 plus 136 equals 180. These all add up to 180. All right. Now, angle 1 plus angle 2, again, equals 180. Therefore, angle 2 equals the sum of 3 and 4, which is 136. Therefore, 2 equals 3 plus 4 again. That's the same thing. Equals the sum of the measure of the two remote interior. Word problem on direct variation. Suppose that the distance a car travels varies directly with the amount of gasoline it uses. Now, direct variation, when we say it varies directly, it means that there's a multiplier involved directly. So, for example, if a car travels, we could say, like a simple example would be, if a car travels, if a car uses 1 gallon, it travels 10 miles. 2 gallons, 20 miles. Okay, so what we're talking about is the miles traveled equals 10 times the number of gallons used. This is direct variation, where one variable equals the other one times a constant. So that's what we're talking about here. It says a certain car uses 18 gallons to travel 630 miles. So in this case, we don't know the constant, okay? How many miles can the car travel if it has 27 gallons of gasoline? So all we got to do is find this constant. Now what we can do, there's two ways to do this. You can do this with the proportion or with the equation. Let's do it with the equation since we have it set up here. We can say the car uses 18 gallons to travel 630 miles. Okay. So to solve for k, we divide both sides by 18, and we get k equals 35. So now my new equation is miles equals 35 times gallons. So 27 gallons, what's going to be the miles driven? Let's multiply it out. 27 times 35. 945. And that's it. All right, next. This thing varies directly, right, according to the second law of motion. Suppose that 24, so we're talking about force varies directly with acceleration equals some value times acceleration. Suppose that 24 newtons of force results in an acceleration of 4 meters per second. So now let's find the constant. I'm going to divide both sides by 4, and guess what? My constant is 6. So that means F equals 6 times A. If the force is changed to 36, what is the acceleration? Let's solve for A, divide both sides by 6, and I get A equals 6 meters per second squared. Last but not least, on a given planet, the weight of an object varies directly with the mass. So weight varies directly with mass. An object whose mass is 6 kilograms weighs 60 newtons. Okay, so let's first find that K value. K equals 10, right? Therefore, weight equals 10 times mass. Now we have a mass of 9 grams. So let's plug it in here. 9 times 10 equals the weight. The weight is therefore 90 newtons. Okay, next, finding outputs of a two-step function with decimals that models a real-world situation. Okay. Laura rented a truck for one day. There was a base fee of $15 and there was an additional charge of 9 cents for each mile driven. The total cost in dollars is given by the following. What is the total rent if Laura drove 20 miles? All we got to do, okay, is plug in 20 for x, because 20 is represented, and x represents the miles. So it's C equals 15 plus 0.09 times 20. Okay, 20 times this is 2 times this would be 18.18. So 20 times this is 1.8. 15 plus 1.8 is 16.8. So it is 16.8 or $80. $16.80. Same thing here. I'm not going to really read this. I'm just going to say, what is the remaining balance on the card if Carlos bought 50 prints? Again, X represents the number of prints. So we're plugging this value in over here. 0.5 times 50. Okay. So 5 times this would be 25. 50 times, or 0.25. 50 times this would be 2.5. 35 minus 2.5 is 32.5. Last but not least, 40 copies. X represents the number of copies. So 0.08 times 40. 8 times 40 would be 320. Right? But since we're multiplying it by 0.08, we'd have to move the decimal over once, twice. Right? Because multiplication, two numbers to the right of the decimal, we have to move it 2 spots to the left. So 3.2 plus 14.25 is 17.45. Choosing a graph to fit a narrative, advanced. All right, for each scenario, choose a graph that gives the best representation. John stands on a high dive platform for several seconds. So, and we're talking about distance above pool, and then diving in the pool, and then swimming around, then climbs back up to the high dive platform. So at the end of the day, he should be up high on a platform, and then he should start here and he should end here. Okay, well, this is the only one where he ends at the same height. Here, this is almost right, right? Oh, no, you know what? He says he climbs back up toward the high dive platform. It never says he reaches it. So this actually doesn't make sense because it doesn't say he got there. This one is actually looking better. He's on the high dive platform, boom, jumps in the pool, swims around for a bit, and then starts climbing back up. And this makes sense too. Look how steep this fall is because this is almost like a straight fall. This makes no sense. This is going up and then down. Doesn't say it says he started up on the high dive platform. And this is like he climbs up a little bit and then this doesn't make any sense. So it's this guy. Throughout last month, the Robinson family's pool was full of water. 3 weeks ago, the pool began to leak and it lost water at a constant rate. So we're starting off with going down, right? And the following week, there was big rain and the pool almost overflowed. So it's like, now let me see here. I think this one's it because the Robinson's pool is full of water. Then, so this is like for a week, it's just normal. Then 3 weeks ago, it starts leaking. And then all of a sudden, boom, there's a big rain and it spikes and it almost overflows. So it looks like this is being full and it's about to surpass the point of overflowing. So this makes the most sense. I don't think any of these other ones make any sense. This one's losing, but this one doesn't look like it's overflowing. This one makes no sense. Let's see. Okay, John is delivering pizza to Mark's house. He drives at a constant speed towards the house until he hits a traffic jam. And this is, we should be getting closer to Mark's house, right? So these don't really make sense. So he drives at a constant speed towards the house until he hits a traffic jam, stops for several minutes. After that, he starts up again and drives at a faster speed than before. These is getting farther away, right? The distance is increasing, so these two are out. This one is like he's going farther away, traffic jam, then he's going closer. This one he's kind of going closer, stuck, same rate, same place, and then boom, way faster. So this is what was being described. I like that. Next, Frank is working out by riding his bike. He starts by biking slowly. So first his speed is slow, not really high like this, So one of these two, slowly. Then he gradually, he gradually starts picking up his speed. I like this until he reaches his peak. Then he maintains his peak speed for the rest of the workout, and then this makes sense. This one is almost good, except there's no peak where he maintains, so it's this guy. A sightseeing ship stopped in the water for an hour miles from the shore. We're talking about distance to the shore. So it stopped a mile from the shore. Then the captain heads the ship back to the shore. Heads back to the shore at a constant rate. The ship docks at shore, then returns to the open sea. So we're stuck. We're out in shore, then we're like, boom, 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 let's go back to shore. Let's dock here for a while, and then let's head back out. This one looks right. Population of a large city is constant for several years, so we should start off with a flat line, so it's only this one or this one. Then the population grows very quickly for a few years. Boom, that looks like this, until the city becomes quite crowded. After this, the population still grows, but grows more slowly. So it's still growing, but more slowly. Here, it's just flat lines, so it's this guy. Transformations, properties of rotated figures. Rotate the figure 180 degrees clockwise about the origin. So clockwise is going 1 this way and 2. That's 180. Then decide if each statement is true or false. If two sides are parallel in the original figure, then these sides may not be parallel in the final figure. That's false. That shouldn't affect ever anything about parallel relationships. The final side lengths are the same as the original side. Yes, true. The final angles are larger. No, nothing changes the angles. The original and the final figure may not be congruent. And false. They're always congruent. It's the same. We're just rotating. Okay, counterclockwise about the origin. This would be counterclockwise, 90 degrees. Boom. Okay. The final angle measures are the same. Yes. Final side lengths are longer. No, nothing changes. The original and final may not be congruent. False. They are congruent. If two sides are parallel in the original, they may not be parallel. That's false. They have to be the same. All right, next, rotate the figure 270 degrees clockwise about the origin. So we're going to go clockwise. We're going to go 90, 180, and 270. Then decide if each statement is true or false. So the final side lengths are the same as the original side lengths. Yes. The final angle measures are the same. True. If two sides are parallel in the original, those sides are parallel in the final. Yes. And then they may not be congruent. False. They are congruent. All right, there we go. Next. Area of a trapezoid. I can see it's slowing down a little bit, so let me log back in. Identifying rational decimal numbers. Okay. For each number, determine if a number can be written as a fraction. Now, when we're talking about rational numbers, the definition of a rational is, can it be written as a fraction? Can it be written as a number over a number? And that's what we're going after here. So we're trying to figure these out with repeating decimals, or if it's a terminating decimal, definitely can, meaning it doesn't go on and on, it's definitely rational. So here we have a decimal that's non-terminating, but it's repeating 919191. So can it be written as a fraction? Yes, because it is a repeating decimal. Okay. This, no, because it is not repeating and it's not terminating. The three dots, the ellipses there, indicates it goes on forever. And by the way, this could be a repeating decimal theoretically. It could be 0.63758, 63758, so on and so forth. But we're going to assume that we see no pattern, therefore it doesn't repeat and it doesn't terminate. So it's not rational. This terminates because there's no dot, dot, dot. So it's a terminating decimal. Yes, it's a fraction. This is a repeating decimal, right? And so since it's repeating, we've got that bar over the top. And yes, it is a repeating decimal. Now, the only thing I'm scared of here is, now that I think about it, there's no bar over this, which means it could be 0.9191912, so on and so forth. So I don't know if they're testing on this must have a bar or not. So this could be wrong. This could be say no and say it's neither. But let's check it out and see what they say. Yeah, it's correct. Next, this is definitely repeating. This is definitely repeating. It looks like we got 8s going on forever. So that's fine. Even though that 2 is different, once we see a pattern of 8s, it's repeating. No, because it's neither. And then yes, because this is terminating, it ends. Yes, this can be a fraction because it's terminating. Yes, because it's repeating. Yes, because it's repeating. And no, because it's neither. Now we convert a mixed number to a terminating decimal. Okay. So this is an interesting question because basically what we do is we know the whole number's there, and it's just going to be like 12 point something. But it's converting this. Now, the typical way is we take the numerator and we divide it by the denominator. But here, it's got a base of 25. So there's something easier we can do. I can just multiply the top and bottom by 4. And I get 44 over 100. And since it's 44 over 100, it's really the same as 0.44. So this becomes 12.44. If I did the division, you would see the same thing happens. 25 goes into 110 4 times. 25 goes into 100 4 times, and it's 0.44. So it's 12.44. Next, 2 and 47 over 50, so it's 2 point something. And I'm going to do the same thing since we can turn this into 100 by multiplying the top and bottom by 2. I have 94 hundredths, or 2.94. Then we have 24 and 7/20. Multiply the top and bottom by 5 to get to 100. So we have 35 hundredths. So it's 24.35. Area of a trapezoid. What's the formula for the area of a trapezoid? All right, so this is pretty cool, actually. It's the average of the bases, and I'm going to explain what the bases are in a second, times the height. Okay? The bases are the parallel sides. So in this case, 17 and 8 are my bases. And my height is this value here that's perpendicular to the bases. And now we can evaluate. 17 plus 8 is 25 over 2 times 4. In this case, I'm not going to divide it by 2 because it will be a decimal. Instead, I'm just going to multiply across the numerator. And I get 100 over 2, which is 50. Oh, meters squared. Oops, let's actually not delete this. So I'm going to leave this up here. Okay, my bases are 17 and 9, and my height is 7. So the 17 plus 9 is 26 over 2 times 7. That becomes 13 times 7. 7 times 13 is 91. And it's always yard square. It's always the unit squared when we're talking about area. Okay. So now we have the bases are these sides, 12 and 6, and the height is 9. So 12 plus 6 is 18 over 2 times 9. 18 divided by 2 is 9. 9 times 9 is 81. Uh-oh. There we go. volume of a pyramid. Okay. So the way we calculate the volume of a pyramid is we do the base, whatever this base is, so it's 5 times 3, which is 15. We do the base times the height times 1/3. Okay. So in this case, my base is this rectangle, so 5 times 3, which is 15. And the height is 5. And there we go. So 1/3 times 15 is 5. Times 5 is 25. And since we're talking about volume, we're talking about inches cubed. Next, 1/3 times 5 times 4, which is the base, which is 20, times 7. Okay. And in this case, we don't have a nice, it's not going to be divisible by 3, unfortunately. So this is 20 over 3 times 7, which equals 140 over 3. Which I wonder if we can put that as an improper. I think we can, maybe. Let's try it. Oh boy, wait, that doesn't look right. Let's see if it gives it to us. Cool. And then we get 1/3. The base is 32 and the height is 9. Now I'm going to do something, because multiplication, we don't have to do it in order if it's a big string of multiplication. So I'm going to show you a nice trick. I'm going to multiply the 1/3 times 9, because that evaluates to 3. And then it's just 3 times 32, which is 96. Next, suppose that the genders of the 3 children of a family are soon to be revealed. An outcome is represented by a string of the sort GBB, meaning the oldest child is a girl, second oldest is a boy, oops, youngest is a boy, right? Girl, boy, boy. The 8 outcomes are listed in the table below. Note that each outcome has the same probability. For each of the 3 events in the table, check the outcomes that are contained in the event, then in the last column, enter the probability. All right. So these are all the different ways it could roll. We could have girl, 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 boy, girl, boy, boy, girl, girl, boy, boy, girl, girl, boy, etc. This is every single outcome if you're going to have 3 kids. So 2 or more girls. So there's 2 girls, 2 girls, or 3 girls, 2 girls, 2 girls, 2 girls. So it's a probability of 4 out of 8, which is 1/2. A boy on the first birth. So anywhere we see boy, 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 and boy. A boy on both the first and last births. So that would be boy, boy, 1 here. So that's 1 out of 8. Is that it? Okay. Oh. And last birth, did I miss one? Oh yeah, I did. This one. Sorry, it's 1/4, or it's 2 out of 8, or 1/4. A coin is tossed 3 times, so this is the same idea. An outcome is represented by a string of the sort HTT, meaning that could be heads, tails, tails. Okay. So now we're going to look at these events and find the probability. A head on both the first and last tosses. So head on first and last. Oops. First and last. So that's 2 out of 8, or 1 out of 4. No tails on the first 2 tosses. So heads, heads. Heads, heads. So again, we have 1 out of 4. Head on the last toss. So 1. Head there. Head there, head there, head there. Okay. So that's 4 out of 8, or 1 out of 2. Okay, a girl on the first birth or the second birth. Again, this is girl, boy. You know, G is girl, B is boy. So a girl on the first or second. So girl on the first, girl on the second, girl on the first, girl on the second, girl on the first, girl on the second and first. Okay. So that's 6 out of 8 or 3 out of 4. A girl on both the first and last. So here, first and last. First and last. So that's 2 out of 8 or 1 out of 4. And then a girl on the second birth. One here, 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 and here. So that's 4 out of 8 or 1 out of 2. Okay. Okay, this might be the last one for today. Here we go. Solving a word problem using a one-step linear inequality. Jessica will run more than 26 miles this week. So far, she has run 17 miles. Whoops. What are the possible numbers of additional miles she will run? So she's going to run an additional X. And we know that she's going to run more than 26. There's my inequality. And they want us to actually use T for miles. Okay. So now we just isolate and solve for T. So I'm going to subtract 17 from both sides. And I get T is greater than 9. And that's it. So you're going to run more than 9 miles. And we indicate it like this. So Christine buys candy that costs $5 per pound. She will buy less than 6 pounds of candy. What are the possible amounts she will spend on candy? Okay. So it's, and use C for amount in dollars. Okay, so C is the amount of dollars. Whoops. C will be less than, she's going to buy less than 6 pounds. 6 pounds times $5, right? $5 per pound. Therefore, C will be less than $30. She's going to spend less than 30 bucks, and that's it. Josh runs each lap in 4 minutes. He will run at least 48 minutes today. Okay. 48 minutes today. What are the possible number of laps he will run? Okay. So N is the number of laps. And N, so it's like N is greater than or equal to 48 divided by 4. Because the number of it's minutes divided by 4 is the number of laps. And we're going to run at least 48 minutes. So this is my number of laps. So N is greater than or equal to 48 divided by 4, which is 12. Okay, that is it. Let's see where we got to on the home page. We got 71%. That's really cool. So only 29% left until this pi is complete. And that is it. So thank you guys so much for joining. Again, new SAT content will be out on Wednesday, but I'm probably going to do a couple more live streams this week, all about trying to finish this ALEKS pi. I'm going to do my best to finish by the end of the week. Don't know if that'll happen, but we're going to try. Thank you guys so much for joining, and I'll see you guys next time. Take it easy.